Hello, dear students. Namaste. How are you? Hope you are good and I am also fine. Today in this class, we are going to discuss about the force and motion, which is in unit 7 of your grade 9 science and technology book. In our class, we mainly focused on the Newton's second law of motion. Let me show you the topic of discussion in today's class. In our class, today we are going to discuss about Newton's second law of motion. Actually, this Newton's second law of motion gives the measurement of force, which is given by the formula F is equals to m into A n. You have already used this formula in lower classes also, but today we are going to derive this relationship mathematically. And we are going to solve some numerical problems by using formula F is equals to ma and other equation of motion. And at last, we are going to discuss about the various application of Newton's second law of motion in our daily life. So, dear students, are you excited to learn about these topics in today's class? Just take all the essential necessary materials like book, ball pen and copy to note down the important things. So, let me start today's class with this picture. Look at this picture. In the first picture, you can see a person is trying to pull 10 kg of mass, and in the second picture, another person is trying to pull 20 kg of mass. There are the two loads 10 kg of each. So, the total mass of this load is 20 kg. And in this another picture, look once. The difference between these two pictures is that in the first picture, only the cyclist is there, but in the second one, there is a person sitting in its backside. Just like as the first picture, in the second picture also there is a difference in mass because of the extra mass of the person who is sitting in the backside of the bicycle. And in this figure, look once, this load of mass m is pulled by the force F with the help of rope, so that the acceleration A is produced on the body. This body begins to accelerate. Accelerate means the body start to move with greater velocity, isn't it? So that due to the change in velocity, some acceleration is produced in a body. So, in the same card, if we add some extra mass in the last figure, or for the same mass, we can apply the more force. If the applied force is double, look once, if the force applied on the body is double, then what will happen? The force is double just by pulling this cart with the two person. Look once, the two person are trying to pull this cart by applying the force 2F. If the mass is same, then the acceleration produced on this body will be double. And the third one, if the mass is increased to double its initial value, look once, m plus m is equals to twice m, and if the force applied is same, then the acceleration will be decreased. But just from this figure, it is difficult to understand this concept. So that in order to make it clear, I am going to show you one simulated video. Actually, the simulation is the techniques of making computer model of something, especially for the study purpose. So, students, look at this video. In this video, look once, the mass are different. In the first card, there is 3 kg of mass, in the second 6 kg of mass, but the person, if the equal force is applied on these two cards, just try to find out which one will move faster or which one will accelerate more. In order to find the answer of these questions, let me play this video. So, let me play this video again once. From this video, we can conclude that if we exert an equal force on the two bodies, then the body with the less mass accelerates faster and the body with the more mass accelerates slowly. Similarly, in another case, Suppose let us take the equal mass on both of these cart. Okay, 10 kg of mass. We are taking 10 kg of mass in both of these cart, and if we exert unequal force to them, look once. In first, we are applying just 2 Newton of force. In second, 4 Newton of force. So, while performing this type of activity, we should take one thing constant. In Newton's second law of motion, we are mainly going to discuss about the three physical variables. They are force, mass and acceleration produced on the body. Out of these three variables, one should be taken as a constant. Look at the figure. We are taking the mass as a constant and to observe the change in acceleration produced when the different force is exerted on this body. So, look at this video once. So, let me play this video once again. So, from these short clips, we came to the conclusion that if we take the equal mass 10 kg of mass and when we apply the different amount of force, if we exert the 2 Newton of force in the first body and the 4 Newton of force in the second body, then higher the magnitude of the force applied on the body, then such body will accelerate faster. It means that in second figure, we apply the double the force than the first one. So, it accelerate faster than the first one. Now, this type of activity can be performed in our lab by taking this type of arrangement. Look once. A trolley is taken and the mass of the trolley can be increased or decreased by adding or removing the washer in it. On the another hand, look once, these are the accelerating washer. The name itself says that when we add more washer in it, if we pile up more and more accelerating washer in it, it accelerates the vehicles, which is measured by calculating the time interval between these two channel gate. In this way, we can experimentally calculate the acceleration produced on a body when the different amount of force is applied on them. Now, from this activity, we are going to find out the relationship between force F, mass m and acceleration a. Dear students, keep in mind that in our class, if we use this symbol F, m and a, you should understood that F means force, m means mass and a means acceleration produced on a body. So, as a whole result of this activity can be concluded in two sentences. Look here, the body with the less mass accelerate more when the constant force is given to it. Constant means equal magnitude of force is given to it. Body with the less mass accelerate more or accelerate faster, and vice versa means if the mass of the body is less and when we apply the constant force to the body, then the body accelerate less. On the other hand, for the constant mass, the body will accelerate faster if the more force is applied to it. It means if we take the constant mass, suppose if we take 2 kg of mass, 2 kg of mass each, it means that the mass is constant. And when we exert the different amount of force, let's say apply 10 Newton of force to the first body and 20 Newton of force to the second body. Mass is same means obviously we can say that in the second case, when we apply the 20 Newton of force to the body having the same mass 2 kg, it accelerates faster or moves with higher velocity. Now, let us discuss the questions given on the screen related to the Newton's second law of motion. Why can we walk faster without carrying load? While carrying a load, the mass of the person along with the load increases. As a result of this, we cannot walk faster with carrying load. And another is, what is the difference in motion of bicycles with the cyclist and the passenger at the back? What is the difference in motion of the bicycle with the cyclist and the passenger at the back side? When the passenger is sitting at the back side of the bicycle, the mass of the bicycle along with the cyclist and the passenger increases. As a result of this, bicycle moves slowly. And the third one is, what will happen if the driver use the accelerator, they press the accelerators in the vehicles or the automobiles, then the vehicle is moving and then applies the brake. When we push the accelerator, then the acceleration is produced in the vehicles. As a result of this, vehicles move faster, and if the brake is applied after accelerating, then the acceleration of the vehicles is decreased. As a result of this, the motion of the vehicles can be controlled by applying brake. Now, from all this above activity, we came to the conclusion that we came to the situation of defining the Newton's second law of motion. Newton's second law of motion states that acceleration produced on a body is directly proportional to the net force. In second law of motion, there is acceleration, force act on a body, and it is inversely proportional to the mass of the body. So, Newton's second law gives the relationship between these three physical quantities. They are acceleration, force, and mass. We can memorize the Newton's second law of motion in alternative way by the help of its mathematical expression. Look once. A means acceleration. Acceleration produced on a body is directly proportional to the force applied on it. It means that when we write this type of expression, look once, acceleration is directly proportional to the force applied on it. Here, acceleration, look once, as well as the force. Nothing is there means we can write 1. Acceleration and force both are in the position of numerator. So, if they appears in the numerator, these variables are called as the directly proportional, which means that with the increase in force act on the body, acceleration is increasing. It means that acceleration is increased with the increase in force act on the body. Similarly, the another expression is, let me write, acceleration is inversely proportional to the mass of the body. This sign is proportionality sign. We can do all the other mathematical calculations just like that of is equals to, but we cannot write equals to sign here. Acceleration produced on a body is inversely proportional to mass. It means that less is the mass, more is the acceleration produced on a body, and vice versa. Now, let us derive this Newton's second law of motion to get the mathematical relation F is equals to ma. Here is a one question, my dear students. Look here, prove F is equals to ma. We should understand that F means force, m means mass, and a means acceleration. So, we are going to prove this relationship. So, at first we should define. Let us consider the body of mass m is acted by the force F to produce an acceleration a on the body. It means that we have one body whose mass is m, body of mass m, it is acted by force F. When the force is act on the body, body is displaced in the direction of the force. Due to the displacement of the body in the direction of force, some acceleration is produced in it, which is denoted by a. And in this derivation, we are going to find out the relationship between force, mass, and acceleration produced on it. As we already known that acceleration produced on a body is directly proportional to the force, which can be expressed in the mathematical equation in this way. Acceleration is directly proportional to force, and actually this equation gives the relationship between only two physical quantities. So, the third one, what is missing here? Obviously, the mass. Mass should be taken as a constant, or the mass is constant. Okay. Similarly, acceleration produced on a body is inversely proportional to the mass of the body. We are going to write the relationship between acceleration and the mass, means the force should be taken as a constant. Okay. Look here, acceleration is inversely proportional, means these two variables, one should be written in the numerator and another in the denominator. That's why they are inversely proportional. The meaning of inversely proportional is when we increase the mass, acceleration is decreased, okay, or vice versa, or with the increase in mass, acceleration decreases, or vice versa. Now these two expressions, look once, what is there in the left side of this equation? There is only a. So we can combine this relation. Keep in your mind that we are not going to multiply this relationship, we just combine. So instead of writing these two equations separately, we can combine these equations, and this gives the expressions in the form acceleration is proportional to F by m. Actually, this when we get the expression after combining this equation, then what happens? No need to mention these two equations separately. All those informations carried by these two equations can be expressed in the form of single equation by combining this equation. Student, you may be confused about, it looks like that we are multiplying the equation, but it is not true. Look once, in the right side we just combine this. Combine means acceleration is proportional to force, both are in numerator. Acceleration is inversely proportional to the mass because acceleration is in numerator and mass is in denominator. And I already told you that you can proceed all the mathematical steps similar like that of is equals to, but you cannot write is equals to. So when we cross multiply m and a, it becomes ma. Ma is proportional to f. We can just change the left side into right side and right side into left side, because we are going to derive the relationship f is equals to ma. Look once. Now to change proportionality sign into is equals to sign, we require some constant. This constant k is force constant. It means there is a little bit difference between is equals to sign and proportionality sign. If you want to change proportionality sign into is equals to sign, you should bring any constant, bring constant, and in this case we just take k, we just take a k as a force constant, okay. And just the reverse method, while changing is equals to into proportionality sign, what do we need to do? Obviously we should remove constant. Remember these steps. If you want to convert proportionality sign into is equals to sign or is equals to sign into proportionality sign, only the difference is that whether we should bring constant or remove constant. Now this k is force constant, which is called proportionality constant also. The name itself says that it is used to change the proportionality sign into is equals to sign. Now let us choose all this physical quantity as a unit value. Unit value means just the magnitude is 1 with their SI unit. Force is equals to 1 Newton, mass is equals to 1 kg, acceleration is equals to 1 meter per second square. When F, M and K all are 1, then the value of K becomes 1. Let me show you this expression. We get this relation F is equals to kma when the force is 1 Newton, K, we don't know what is K, but mass is 1 kg and acceleration is 1 meter per second square. Then 1 Newton is equals to K into 1 kg meter per second square. As you know that kg meter per second is square and Newton, these two are the same unit, only the difference is that Newton is expressed in terms of fundamental unit. Kg, meter and second all are fundamental unit. So when these two units are equal, they get cancelled. So the value of K becomes 1. And if we replace the value of K is equals to 1, then we get the final expression F is equals to m into A. So Newton's second law of motion gives the quantitative measurement of force. Actually, by using this formula, we can measure the quantity of force numerically. Now let us define the 1 Newton force. Actually, the unit quantity in physics are really important to define them. Look once, in order to define the 1 Newton of force, look here, mass is taken as a 1 kg. When the force, unit force 1 Newton is applied on the body displays through certain distance in the direction of force. So as an effect of force, the velocity of the body is increased. Look at the figure, the velocity of the body is increased from 1 meter per second to 2 meter per second. In time, time is displayed by the clock. Look there, 1 second. In the duration of time 1 second, if its velocity increases from 1 meter per second to 2 meter per second, you know that what is the change in velocity? So easy, 2 minus 1 is equals to 1. So 1 meter per second square is the acceleration produced on body. It means that, look here, from Newton's second law of motion, F is equals to m into A, mass into acceleration. So if we take F as a 1 Newton, let us take their unit quantity, F 1 Newton, mass 1 kg and acceleration 1 meter per second square. So the force is required to produce an acceleration on the body. When the force is applied on the body, then the body accelerates in the direction of force. As a result of this, acceleration is produced on it. So 1 Newton of force can be defined as a force required to produce an acceleration of 1 meter per second square on a body of mass 1 kg. So in order to define the unit physical quantity, you must know their physical relationship at first. Look there, force is equals to mass into acceleration. Substitute the value of each physical quantity by their SI unit. Force is equals to 1 Newton, mass is equals to 1 kg, acceleration is equals to 1 meter per second square. So when the force is applied on the body, then the body accelerates in the direction of force and some acceleration is produced on it. As you know that Newton's second law of motion gives the measurement of force, or the magnitude of force can be measured by using mathematical relationship obtained from Newton's second law, which is F is equals to ma. So we are going to solve the numerical problem. Look here, a car is moving with the speed of 72 km per hour and the brake is applied on the car, so it is stopped after covering 50 meter distance. When the brake is applied on the car, it covers certain distance because of its momentum, so that car stops only after covering certain distance, which is 50 meter of distance. Now calculate the retarding force. Retarding force means, in general, the force causes the motion of the body, but the force applied by the brake on the car is retarding force. This force is applied to stop the car. If the mass of the car is 1000 kg. So before solving this numerical problem, let me tell you some steps to be followed while solving numerical problem. We should follow some steps while solving numerical problem. Let me explain this. Read the question carefully and understand the situation. In general, the numericals in science are difficult for the student because they do not understand the situation. If they are able to convert the situation into the mathematical form, then it would be easier to solve numerical problem. And another is identify the physical quantity involved in the equation. We should identify the physical quantity. So if we are going to find out the measurement of the force, obviously the physical quantities involved may be force, mass, acceleration, etc. So you need to find this physical quantity in the question. And this third step is also very important. Check whether the physical quantity, all the physical quantity means they are measured in different unit, but before solving numerical problem, all the physical quantities should be expressed in the same unit, and better to use SI unit, which is very common for the students. Identify the appropriate formula to solve the problem. There may be a different formula related to the physical quantity, but you need to find out the appropriate formula. The formula is appropriate if there is only one unknown variables. So while using appropriate formula, there should be only one unknown quantity or unknown variables to find out. Find the value of unknown quantity. If the force is asked in the questions, you need to calculate the force. If the mass is asked in the questions, you need to calculate the mass, which is called as unknown quantity. And at last, don't forget to write the unit in answer. You must write down the unit. Only the magnitude doesn't give any sense in physical quantity. So at last you must write their unit. Now let us solve these questions. I am going to solve this numerical problem. Let me read this numerical again. A car is moving with the speed of 72 km per hour and the brake is applied on the car, so it is stopped after covering 50 meter distance. Calculate the retarding force required to stop the car if the mass of the car is 1000 kg. Let me write down the physical quantity on the board. Here, a car is moving with the speed of 72 km per hour. Here, this is the initial velocity of the car. What is this? This is the initial velocity of the car, which is denoted by u. What is the initial velocity of the car? 72 km per hour. So 72 km per hour, is it SI unit? No, but generally the speed of the car is measured by its odometer in kilometer per hour, but in science SI unit is meter per second. So let us convert this 72 km per hour into SI unit. Write down 72 into 1 kilometer by 1 hour, right? 1 hour. 72 as it is. You don't need to convert the numeric value, but 1 kilometer and 1 hour, we are going to convert this value. So 1 kilometer is equals to 1000 meter. 1 hour is equals to 60 into 60 second. Let us cancel this 0, 0, 0, 0. 6, 6 are 6 12s are 72 and 6 2s are 12. Then its velocity becomes 20 meter per second. Although the initial velocity of the car is given at 72 km per hour, but it means we should understood that it is 20 meter per second. Let me write this, and similarly the final velocity of car v is equals to 0 meter per second. Why 0? Because the car is stopped after covering certain distance when the brake is applied on it, right? You should understand that if anybody stopped, then its velocity becomes 0. Now, what is the distance traveled by car? Distance traveled by car S is equals to 50 meter. Now, from equation of motion, we know that, we know that S is equals to u plus b by 2 into t. What is the distance traveled by car? 50 meter. Okay. And what is the initial velocity? 20. Finally, 0 by 2 into t, right? Or 50 into 2, 100 by 20 is equals to t, or t is equals to 5 seconds. The car is stopped after 5 seconds. Okay, it covers a distance of 50 meter and it stopped after 5 seconds. This time is required to calculate the acceleration because we need to calculate the retarding force. Now, to calculate the retarding force, we require the acceleration. So, at first we need to find out the time required to stop the car, although it is not asked in the problem. Okay. Now, let us calculate the retarding force by using the formula F is equals to m into a. Now, we know that the time required to stop the vehicles is 5 seconds. What is its initial velocity? 20 meter per second. Final velocity is 0. Now, we need to calculate the force, retarding force. Okay. Now, we are going to calculate the retarding force by using Newton's second law of motion. Let us use, according to Newton's second law of motion, F is equals to m into a. We know that m means mass, m into a means b minus u by t. Okay. So, mass, what is the mass of the car? 1000 kg. Velocity 20 minus 0 by time is 5 seconds. So, 5 2s are 10. So, 200 into 20, 2 2s are 4000 Newton. Retarding force is required to stop the car. Okay. So, in this way, students, we can practice the numericals given in the exercise section of your book. Now, students, let us discuss about the applications of Newton's second law of motion in daily life. Look at the picture. The truck loaded with the goods moves more slowly than the empty truck. It is due to the Newton's second law of motion. More is the mass, less is the acceleration. Similarly, some practical application of Newton's second law of motion. Look once, this picture shows the acceleration, and this shows the accelerator of the vehicles. When the accelerator is pushed, then the speed of the vehicles is increased. which is shown in the odometer. Look once. When we push down the accelerator pedal, then the force acting on the car increases, which in turn increase the car acceleration. The car mass also plays the role. If the mass of the car is more, then less will be the speed or less will be the acceleration produced on these vehicles. Similarly, look here, another application of Newton's second law is the cyclist. Look once, when we pedal bicycles, we need to pedal bicycles just to move on the road. We are applying force to the pedals, which cause the bicycles to accelerate. In this situation, force is applied by the cyclist to accelerate the cycle. The mass of the bicycles and the rider also affect the amount of force. In this case, the mass of the object is mass of the cyclist along with the mass of the bicycle. If the mass will be more, less will be the acceleration. Similarly, look at the picture. Aircraft industry is shown in the picture. Newton's second law of motion is very important or critical to design the operation of aircraft and rocket, because the mass also plays very important role to fly in air. Therefore, the engineer in this industry, aviation industry, used to use the law. Law means which law? Newton's second law, to calculate the amount of thrust needed to lift off and travels through the space. They are always trying to reduce the mass of the aircraft to increase their performance, to increase the velocity of the aircraft. So similarly, not only in the aviation sector, but it is also used in the automobile sectors also. Look once, in the automotive industry also, the engineers, they are trying to reduce the mass, increase their performance. If the vehicles accelerate faster, so we can reach to the destination in the short time. That's why the Newton's second law of motion is used in automotive industry to design and improve the vehicle's performance. It is very important to design the new vehicles in this field by understanding the relationship between mass, force and acceleration, which is given by the Newton's second law. Engineer can optimize the design of the engine and other component, and all this purpose is to improve the all of this is to improve the fuel efficiency, acceleration and handling. Look here, the another simple applications is, it is easier to push an empty trolley than the loaded trolley. Look once, this is the empty trolley, this is the loaded trolley, so that it is easier to push an empty trolley than that loaded with the mass. So dear students, look at the picture. In an accident, speeding car has more velocity, so it exerts more force due to its higher momentum. Actually, the momentum is the product of mass and velocity. Speeding car means it moves with higher velocity, which multiply to its mass, and it exerts higher momentum. Keep in your mind that force and momentum, they are also interrelated. Similarly, driving at high speed increases the risk of accident, because such vehicles have more momentum or they are moving with higher velocity. Therefore, the speed limit are imposed to ensure the drivers stay safe. Just for the safety purpose, speed limits are kept while driving on the road also. Now, on the basis of the discussion in today's class, let us try to solve some objective questions or multiple choice questions. Look here, choose the best alternative. Newton's second law of motion gives the, look here, what are the options? Definition of force, measurement of force, nature of force and type of force. So, if you have chosen this option B, measurement of force, as your answer, then this is the correct option. Second law gives the measurement of the force. Look here, the second question. What is the force required to produce an acceleration of 2 meters per second square on a body of mass 50 kg? Here is mass, here is acceleration. We discussed a lot about the formula F is equals to ma. So, although it looks like a numerical problem, it is very short. Just you need to multiply this 50 and 2. 50 into 2, 100. So, the correct option is 100 Newton is required. Similarly, another, which of the following relationship is true? Acceleration is directly proportional to the mass of the body. But Newton's, this is wrong, because acceleration is not directly proportional to the mass. It is directly proportional to force of the body. Check all these expressions one by one. Acceleration is inversely proportional to the mass of the body. So, this is the statement of the Newton's second law. So, the option B is correct. But let me check other option also. Acceleration is equals to force. directly proportional, it doesn't mean that is equals to sign. There should be any constant. So, this is also wrong. The third one is acceleration is inversely proportional to force. This is also wrong because acceleration is directly proportional to force. So, what would be the correct option? Yes, obviously acceleration is inversely proportional to the mass of the body. And the last one is, if the force applied on the body is double and the mass is reduced to half, then the acceleration produced on the body is. So, let me write something to solve this problem. We know that, look here, F is equals to m into A, or we can write F by m is equals to A, or we can write A is equals to F by m also. Now, read the questions. Force applied on the body is double and the mass is reduced to half. So, let us replace that. The new acceleration would be A dash. When the force is double, then it becomes 2F, and the mass is half, then m by 2. So, it becomes 2F into 2 by m, or which is equals to 4F by m, or 4 into A. So that the acceleration is increased by how many times? Just you need to use the formula, replace the value. Why we are writing 2F here? Look here. Why we are writing 2F? Because the force is increased by 2 times. And why m by 2? Mass is reduced to half. So, the acceleration will be increased by 4 times. Therefore, the correct option is increased by 4 times. Dear students, in today's class, we discussed about the Newton's second law of motion. We have derived the relationship between force, mass and acceleration and get the relationship as F is equals to ma and solve some numerical problems. There are other numerical problems given in your book. So, try to practice this numerical. I will be discuss about the another third law in the next class. Bye bye.